5 months of complete silence on my channel. Where was I? And how exactly did the life of an undergrad computer science student go, handling freshers and sophomore? Well, story for another video, but here is a glimpse of a day in my university. I was having architecture classes and my professor asked us to code MIPS to detect even and odd numbers without using branch statements. Yes, you heard that right, without using branch statements. Well, if you do not know, branch statements are just if-else conditional blocks and they allow you to perform conditional operations, of course, in MIPS itself. Cool, but why did this one problem catch my concern and why is it up on this channel? Basically, I completely misunderstood the question. See, when you divide a number in MIPS based on assembly language, the remainder gets stored in a special register named as HI inside the CPU. As well, the quotient is stored in a special register named LO. What my professor wanted was to see the values of the HI and LO using the MFHI move from high and MFLO move from low commands. But I took a step further. Over the course of the next 2 days, I found a way to perform odd and even classifications that require no conditional statements but just some bit manipulation. And here is how it went. My idea was to take a number and then change it to binary. Detect the least significant bit and check if it is a 1 or 0. Substantially, the number with LSB 1 has to be an odd number. See, all the bit positions of a binary representation system is even, may it be 2, 4, 8, 16, 32, 64 or so on. The LSB bit position, that is 2 to the power 0, is 1 and the only odd offset in the entire math. Now by chance, in any binary representation, if the 2 to the power 0th position is 1, then the number has to be odd in nature. Now, let's take two texts, even with a length of 5 characters. Well, 5 because we need to account for the null terminator after the text is over, and another text odd for 4 character length. Before we move further, let's take a look at one more thing. The even odd strings will technically be stored consecutively such that after the word even, there is a word odd in the character array being stored inside the RAM. And most importantly, the term base address refers to the address of the 0th index of an array of characters in this case, and I'm gonna use this term quite often, so don't lose track. Let's take a number input, let's say 9, and converting it to binary, we get 1001, which shows that the input number is odd. So my idea is to take the LSB of it and multiply it with a constant offset, which is 5 in our case, and then add the base address of the string even to the offset. Then this summed value will have the address of the letter O of the text odd to be at the print head, and it will be printed in the console. If I take another number, let's say 8, converting that to binary will give us 1000, and again, as the previous process, if I multiply the LSB of this number with our offset 5 and add the base address of the text even, then we are gonna have the address of the letter E to be at the print head, and then it will be printed at the console by a system call. And that's it. That's the concept. Without using any branching, we can print if a number is even or odd. But there's just one thing. We do not have an active program for it yet. So let's write the code in MIPS. First, let's declare the constants. I will create a prompt label which will be asking for the input, and an even label having the text even in ASCII Z format since it will put a null terminator at the end of the text, and also an odd label having the text odd in ASCII Z format for the same reason. I will also declare a new label called as new line having the new line character in it, and a label with a word data type initialized with 0. Now a word data type can store 32-bit integers in it, and thus the range of the operation in this code is quite big. Now let's start off with the main code. We declare the starting, and under the main label we first initialize a system call to print the prompt for the user to input the number. For that we pass 4 to V0 and load the base address of the label prompt to A0. Okay, pause. Now this is the way we print in MIPS environment. Unlike C and Python, we do not have any print function. Rather, we just load the base address of the text we want to print to the A0 register and pass the value 4 to V0, which accounts for printing text on the console. This will trigger print, and with a system call, thus all the characters will be printed one by one until a null terminator is reached. Alright, next I initialize a general register T6 with the value 5 meticulously. Now this is crucial. The length of the text that you have put in the even level must be of this length. And just so that you don't guys mess up here, the length of the even text is 5 because we have a null terminator at the end of the string, making the length of even plus null terminator to be 5. Alright, now we need to take the input from the user. So I make a system call accordingly, passing 5 to V0, and then I load the number to the T0 register. And here's the trick part. I will perform a bitwise and immediate operation with the 1 on the input number, and this will help me figure out if the LSB is 1 or 0. If the LSB is 1, this particular operation will return 1, and if the LSB is 0, this particular operation will return 0. And for the next step, we multiply the offset, that is in case in the T6 register, and store it in T6 itself. Now T6 will either contain 5 or 0 based on the previous operations. I will load the base address of the event level in T2 and add unsigned T2 with T6 and store the result in T2 itself. This will rewrite the base address of the event level with either shifting the address head to the odd or keeping it in the event itself, depending on whether my T6 has 5 or 0 from the previous operation. Now let's print the string at the computer address T2. I will load 4 on V0, move the base address which is inside T2 to be at the A0, and then make a system call, and that's it. For an additional step, I will print a new line at the end of the code just to make sure that it looks cool when the program reruns. And that's the end. If I put 10 in the V0 register and make a system call, and that does the exit. And there we have it. I guess this should work properly, and for this time I'm gonna use QTSPIM software as the ARC simulator. And I will reinitialize and load the program inside the sim and run it. Let's take the input of number 19 and hit enter. And there we go. It has a right console output. And if I rerun the code with 18 as the input, then I get even as the output in my console. And that's working. And yes, this was surprising to me when this was complete, but it gave me the right results. Well, at the end of the day, it's all on my professor. Without her mentioning the topic in the class, I wouldn't have even thought about it. And that she approved my approach, it was a huge thing to me. Alongside, I have written a C equivalent of this code too, and all the links of this are in the description with the official documentation of MIPS. Do check them out. And that is how I classified even and odd integers without any conditional statements using computer science.